We'll just use good old performance monitor, and I'm going to add in the physical disk. Okay, some people say you should use current disk queue length. I find the numbers jump around too much. I have a tendency to use average disk queue length. And I'm going to add in the spindles that I'm concerned about. Okay, this is average disk queue length of the C drive on this computer. And you can see that it's not doing anything, so let's go down. Sorry, this is the average disk queue length of the C and the E drive. You can see my average number here, and that's what I'm concerned about. Let's just go and force this thing. We will come back to this, folks. Let's force it to do it incremental and see what happens. Okay? Running. Today would be nice. Excellent. See how the number's starting to climb? It is critical, in my opinion, that you monitor these on a regular basis, once a month for your customers. That number there, take away the number of spindles in the array. Okay, in this case it's 1. So if I've got 0.2, take away 1. I'm well and truly below 2. I don't have an issue with this particular computer. But that is disk queue lengths. It is critical on host SATA RAID systems, servers. Those numbers can get quite alarming. And if that number on a host SATA RAID system pushes 40, you will end up with that system freezing at some point. You need to determine what is causing that amount of disk queue length. If it's poorly configured or a poor system to start with, then there's not a lot you can do except highlight that to the customer. Okay. You'll notice here, folks, that I've got 3 jobs configured, a C, E and an F. We'll pick on the F drive. Picking the F drive here by itself in isolation. We're backing it up to the fixed image repository because I create the destination. I'm using continuous incrementals, and this is how I've set it up. And you'll see that it starts at 4:21 and finishes at 11:21, 30 minutes between each one, and away we go. Okay, not on the hour ever. I do not use this top row because it says we're going to do VSS-based incremental backups. We're going to do additional backups down here from Sunday through to Saturday. We are using VSS. Never unselect this box, please, folks. We then go next. You can see all the bits and pieces. I'm not using passwords for encryption. If, however, you have these drives going off-site, please password protect and record that password, folks. Seriously. In the Advanced tab, I've got MD5s turned off, but everything else is the same. And there's my job. Okay? So if I click on the C drive one and I drag this down here, it's at 4:05 to 11:05. The E drive is 6 minutes later, 4:11. And the F drive is 10 minutes later at 4:21. to 11:21. Never on the hour. I will never have an issue with this machine, never have, to do the job. All right. And obviously, if you are using continuous incrementals as I am, on this laptop, it's irrelevant that I'm doing it. The only reason I do it is it takes so long. This drive here in particular takes 4.5 hours to create the backup, folks. That's even when it's going down to a USB 3 device. It's 4.5 hours. I just don't have the time every week to do that, so I use continuous incrementals. Okay, a final thing here, folks, is in the document we say document and test, test, test. Why test? Can't stress enough that testing is critical to the successful recoveries, because we know we can do good backups, but you need to test that you have in fact done good backups. And there's a couple of ways to do that. You can just quickly mount them up. You can use virtual boot All right, mounting is quite effective way of doing it. All you need to do a mount, folks, obviously, is what I was doing earlier on. I'll just quickly flick into here, go to my image repository, and let's go right to the F drive. There's the collapse daily that was made. Let's go next. Let's go next. There's the ballot chain. Next. Mount it up as a drive letter. Can I browse it? Can I see it? Absolutely, that will work fine. I actually use another product of ours called Watchdog. It automatically, every day, will mount those things and do read-only check disks against them so that I don't have to stress about it. If it fails, I get an email to say, oh, we've got a problem with this one, and away we go. Okay? All right, I'll just open this back up. And we have a few questions, folks. So I don't know who the asker is. What about page file for virtual guests? Should they still be 1.5 memory, and should they be installed onto a separate virtual disk? Ultimately, for the best performance, yes, it should be 1.5 times the size of physical memory, and if possible, if extremely possible, put it on a separate virtual hard drive. Definitely. Okay. In physical machines, obviously, there's a cost, an extra cost associated with that. So you can see what I've actually done here is there's my page file there. It's a fixed size, and I've got it on the E drive. It's still the same spindle as the C drive, but I've got it away from the OS partition. So yes, in virtual machines, definitely, I would, if possible, whack in an extra, allocate an extra volume to put the page file on, and then you will get best performance. If VSS is damaged, how do you repair it? And this is Mr. Wyman. Good on you, Mr. Greg. In support, what we have done, because if VSS does get damaged, we need to get it back, folks. Otherwise, your backups will be vSnap backups, which are basically as if the server's crashed. Yes. So can we repair it? Absolutely. In the support area, what we did was I wrote 2 separate scripts, one for 2003, and the later one is for 2008 and 2008 R2. What it does is it goes through and repairs the whole structure, re-registers all the appropriate components. Once that's all been re-registered, it then forces a reboot, and you should be back up and running. Okay? We've only ever had one case where we couldn't fix VSS, and that was because of a mismatch between files. System file checker had been turned off, and half the server was Service Pack 2, Service Pack 1, the other half was Service Pack 2 on a 2003 server. There's not a lot anybody can do to fix that one. Why don't I use MD5? Jamie, I think, asked that question. It's just a simple thing for testing for me, Jamie, and I assume that's Jamie. I apologise, I can't see the full name. But I have a tendency not to use MD5s because it gets a bit difficult to read the lines in here. So quite often when I do have a whole heap of MD5s there, I can actually delete them, like I'll do right now. Does it affect the way the product functions? No, it does not. It just makes the MD5s, especially when Image Manager is involved, it just makes the process a lot more seamless if the MD5s are there. But I quite often want to test a few bits and pieces to ensure that functionality will work with and without the MD5s, so that I know that it's not ever going to get broken, and quite often I'll do that. On production systems that I implement for ourselves, for customers, I will always use, where possible, the MD5s. Okay? What is the purpose of the MD5 file? Good question. The purpose of the MD5 file, folks, is so that Image Manager, for example, you may say, well, I don't particularly trust Image Manager and I want to do it myself. MD5 file is to verify that the file on the disk has not physically changed. And that's what the MD5 checksum file is all about. So Image Manager comes along, for example, and I'll pick down here so you can see them. Would actually help, Jack, if you had one here. There we go. What I can do is I could run a third-party tool against that to say generated MD5. I can then open this one up, all right, see what that checksum is here, and if that checksum is the same as another third-party tool, then that file there has not been modified, and it says it is exactly the same file. That's the whole purpose behind that. It is really intended to be dramatically used or dynamically used in replication, so that we know that when we replicate that file across, we do the same MD5 check, compare it to the MD5 that's there and says, yep, this file after replication is exactly the same file. That's what it's for. And we've got somebody here. Has this webinar been recorded? Would like to go over the weekend. This is being recorded. I'm not quite sure at this point because I'm not in the marketing department at all. I'm not sure where those files will be going, but I'm sure very shortly the marketing people could tell you, yes, they are up on the website, download them and go through them at your own leisure. So the one today is definitely being recorded right now. The marketing department, I will ask them to contact you with regard to that. We have another question here. Is it advisable to run virtual boot on a virtual machine? I'll answer that part of the question first. You can't run virtual boot on a virtual machine because you cannot have a hypervisor on top of another hypervisor. You need a physical machine to do this. Therefore, you can't do it. For example, if I had an ESX machine or a Citrix Zen server or a Hyper-V server and then tried to virtual boot inside that, it won't work. It just says, no, I'm sorry, the underlying structure is not there. The next part of this question, can 64-bit Windows virtual boot on 32-bit machines? The simplest way to answer that question is no. It can't be done. You need to have 64-bit. For example, this machine that I'm using here is 64-bit Windows 7. I can virtual boot just about anything on this machine. As a 32-bit system, I could not successfully boot 64-bit machines. The other crucial fact you must be aware of, folks, the underlying BIOS of this Windows 7 machine must be enabled for the VMT technologies, the virtual technologies. The BIOS on this machine had those capabilities, but it's always been turned off. Our brand new servers here at work, at the Storagecraft office, they have the capabilities of doing this, but it had been turned off in the BIOS. Pardon me. You need to turn it back on. So the short answer to that question, don't try to virtual boot 64-bit machines on 32-bit systems.